Have you ever wondered how a tiny app, maybe built by just a couple of people, can suddenly explode overnight and handle millions of users without just crashing and burning? Well, it's all about something called system design. And in this explainer, we're going to walk through that exact journey, step by step, from zero to millions. So that's the big question, right? How does an app survive that sudden flood of attention when it goes viral? It's not magic, I promise. It's actually a really logical process of finding and fixing one bottleneck after another. So let's start breaking down that journey. Okay, here's our roadmap. We're going to start at the very beginning with a single server startup. It's where everyone begins. Then we'll tackle the user flood and figure out how to solve the traffic and data problems that come with it. After that, we'll get into how modern services actually talk to each other, and we'll wrap it all up with a final blueprint for how to scale. All right, part one, the single server startup. You got to remember, every massive application you use today, no matter how huge, started right here. It's the simplest way to get off the ground. In the beginning, everything is nice and simple. Your web app, your database, your cache, the whole shebang is living on one single machine. It's cheap, it's easy to manage, but, and this is a big but, it has some pretty serious limitations and one glaring critical weakness. And then it happens. Your app gets popular. This is the dream, right? But it immediately creates your first huge growing pain. You have to figure out how to survive the flood of new users. And that one lonely server, it gets absolutely crushed, and fast. For your users, the site slows to a crawl. But even worse, it's what we call a single point of failure. If that one machine goes down for any reason at all, your entire service just vanishes. Poof. So, enter the first hero of our story, the load balancer. The best way to think about it is as a really smart traffic cop. It stands in front of a whole group of servers and directs all the incoming traffic, spreading it out evenly. This is a total game changer, preventing any one server from getting overloaded. Now, for this traffic cop to work its magic, there is one absolutely critical rule. Your web servers have to be stateless. Okay, what does that mean? Well, in a stateful system, a server remembers who you are, so you're kind of stuck to that specific machine. But in a stateless world, any server can handle your request because your session info is stored somewhere else. This little change makes it incredibly easy to add or remove servers on the fly. It's the key to scaling. Okay, great. We've solved the web traffic problem. But scaling is kind of like a game of whack-a-mole. You fix one bottleneck, and another one just pops right up. Now, with all those web servers asking for information, our poor, single database just can't keep up. So how do we fix this one? We start by focusing on the read load. I mean, think about it. On most ops, you spend way more time looking at stuff than you do creating new stuff, right? So the first thing we do is make it easier to read data by making copies of our database. This is called replication. This works with what's called a primary replica model. You have one primary database that handles all the writes. Creating an account, posting a photo. Then that primary database automatically copies all its data over to one or more replica databases. So now all the requests to read that data can be spread out across all those replicas. Performance gets a huge boost. And to make things even faster, we can add another layer, a cache. This is just a block of super fast memory that holds onto data that gets requested all the time. Think about a celebrity's profile page. Instead of hitting the database every single time someone looks at it, we can just serve it from the cache, which is unbelievably faster. And it's not just data we can speed up. All that other stuff, images, videos, style files, we can offload all of it to a content delivery network, or CDN. A CDN is basically a global network of servers. It stores copies of your content all over the world. So a user in Germany gets your images from a server in Germany, not one in California. It makes your site feel almost instant. So, we've scaled our reads, we've offloaded our static files, things are flying. But now we have a new problem. A good problem, but a big one. What happens when you're so successful that you just have too much data to fit on one single database server? The answer is sharding. This is where you split your one giant database into lots of smaller, more manageable databases called shards. You might do it by user ID, for instance. So users with IDs from A to M go on one server, and users N to Z go on another. All of a sudden, you can handle way more data and writes, and you can just keep adding more shards as you grow. So far, we've mostly talked about the infrastructure. But as the system gets bigger, the code itself, that one giant application, or monolith, it becomes a real beast to manage. So the modern approach is to break it down into smaller, independent microservices. But now, all those little services need a way to communicate with each other. And there are two main ways to do this. The first is orchestration. Think of an orchestra with a conductor. One central service is the boss, telling every other service exactly what to do and when. It's direct but very rigid. The second, more modern approach is choreography. This is more like a professional dance troupe. There's no single conductor. Instead, each service knows its role and just reacts to events happening around it. This is way more flexible and resilient, and it's how most massive systems are built today. At the heart of this choreography is something called an event broker, and this quote really nails it. It's an immutable, append-only log of facts. Let's break that down. Immutable means it can never be changed. Append-only means you just add new stuff to the end. It's essentially a perfect, permanent record of everything that has ever happened in the system. This is so powerful because a new service can just come online, read the log, and get completely up to speed without bothering anyone else. Okay, we have covered a ton of ground, from a single server all the way to a globe-spanning distributed system. So let's bring it all home and consolidate everything we've learned into a clear blueprint for scale. So here it is. First, you have to keep your web tier stateless, absolutely non-negotiable. Build redundancy everywhere to get rid of single points of failure. Next, make everything fast, cache aggressively, and use a CDN for your static assets. Then scale your data. Use replication for reads and sharding for writes. And finally, design for the long haul. Break your big application into smaller, decoupled services. And of course, you monitor everything and automate as much as possible. That is the playbook. And there we have it. We've successfully designed a system that can scale to millions of users. These principles are rock solid. But it does make you wonder, what's next? What kind of insane new problems do you run into when you need to serve not just millions, but billions of users? Well, that's a whole other level of complexity, and a story for another explainer.